So today we're going to do sequence mode on the calculator finally, and we're also going to learn some new vocabulary. One of these words we're going to learn today, we're going to talk about the difference between, hang on, my cursor's not working, convergent and divergent, and we're going to graph sequences. We've talked already what the difference is. Does anybody remember arithmetic? The sequence would graph as a what? A line, okay? Some kind of a line, and it could be going down, whatever, okay? Yesterday we talked about geometric sequences. That's not how you spell that. Okay, geometric sequences, do you remember what happens there? Yeah, generally it would look like this, or it would look like this. It could also have some weirdness going on like this, okay? Because if r is negative, every other term is a positive negative, right? But it probably is still getting closer and closer to some value, and that's what we'll talk about in a second. All right, and then we're going to use this summation notation and figure out where to find that on our calculator. All right, I'm going to go over a little bit of vocabulary. This should all sound familiar, so please listen closely, because if it doesn't, I need you to ask questions. Okay, a sequence is an ordered list of numbers. I think I said that each of the last 2 days, right? Each one is called a term. This is new vocabulary. A finite sequence just means like the first 5 terms, okay? Infinite would be when we put that dot, dot, dot. And a sub n, which this is kind of covering there, a sub n means the nth term, okay? When we define it explicitly, that means it has an n in it, or the term number. That's what we said, right? It's based on the term number. So explicit would look like this, okay? Or if it was geometric, might look like that. And it wouldn't necessarily have the n minus 1. Anything with an n. We're going to talk about a lot of sequences today that are not geometric nor arithmetic. Let me give you a real easy one. What are the terms in that one? What's the first term? 1. What's the second term? 2 squared. Okay. 3 squared, 4 squared. But that's not arithmetic nor geometric, right? It's quadratic. All right. Sequences can also be defined recursively. What did we look for when it was recursive? Yeah, it was based on the previous term, so we used this notation, a sub n minus 1. Some books will use a sub n plus 1. They would say this. Means take term n and multiply it by 2 to get the next term. Okay? It's the same kind of notation as this. It's just weirdness. And usually when our book does this, they'll say where n is greater than or equal to 1, or here you'd have to have like, yeah. Anyway, I'm just moving on. All right, so that's what's at the top of your notes. Let's go through a couple quick things here. You have this question. It says find the 6th term of this sequence. Is this arithmetic or, I'm sorry, is this recursive or explicit? This is explicit because it has an n in it. So how can we find the 6th term? Put a 6 in, so it's 1 over 2 times 6 with the 6 in the denominator, plus 2, which would be 1/12 plus 2, or 25/12. Is anybody getting that on their calculator? If you do a math enter. Is that an exact decimal? How can you tell? How can you tell if it's an exact decimal? Okay. This is a repeating decimal, so you can tell it's not exact, but If you have like 10 decimal places on here, that's as much as fits on your calculator, so it's probably not ending. Okay. All right, find the third term of this sequence. We had a little discussion last period, and I couldn't understand what they were confused about at first. But this is supposed to say the opposite of a to the n minus 1, and then over 3. Some of them thought this meant a sub n, and then subtract 1. That it's hard to tell, but that little n minus 1 is all the subscript. Everybody see that now? Okay. So what's the first term, guys? Okay, what kind of a formula was this? When it has the a sub n minus 1, it is called recursive. Okay. The first term given right here is 9. Then we're supposed to plug that in. What's the opposite of 9 divided by 3? Negative 9 divided by 3 is... Then the opposite of that term divided by 3 would become... The opposite of that term divided by 3. Okay. It only asked us to find the third term. So it was easy enough to just keep plugging terms in and find the third term. This third term was 1. We'll come back to this question because we could put this in our calculator in a minute, I think. All right. I want to talk about how to find things on the calculator. I'm going to teach you 2 really old school ways, okay? The first old school way, you could put into your calculator a sequence like a sub n equals 3n plus 2, okay? The first one is to find the word sequence, which is second stat, arrow to the right. Do you see sequence? It's choice 5, right? And then it says, this is where the older calculators, you would just do this with a comma in between each step, Caleb. So you would type in the formula is 3n plus 2. You will get an X probably. Are you guys still in function mode? I'll switch to function mode. It won't matter on this particular question, okay? If you're in function or sequence mode, it won't matter. But I get 3x plus 2. And then I would need a comma x if I was using the older calculator, because it wants to know what variable you're using, which is ridiculous because you just put it in the one above, right? Starting and ending. How many terms do you want it to do? If you don't want it to end, I think you can leave that blank. I'm just going to say let's put the first 5 terms. The step is what do you want it to count by? You want to put in 1, 2, 3, 4, 5. So you actually can leave this step blank, and you don't have to put anything in on there. So Kayla's calculator would look like this. Sequence 3x plus 2, comma x, comma 1, comma 5. Enter, it gives me the first 5 terms. If you said the first 10 terms, try that real quick because I want to show you what happens on some of the newer ones. If you change, whoa, I don't know what I did. Okay. If I change this and say I want the first 10 terms, anybody need me to go back and do it another way? It does go off the screen, and you have to immediately ask it to arrow to the right. If you do anything else, you won't be able to arrow to the right. Like if you go down and do something, or even hit enter again, I think you can't arrow to the right. Somebody's like, I can't see the rest of it. You can only do it immediately after you're generated, I think. Everybody's working? This is old school. I would not use this anyway, because it's like this invisible list. I can't see all of it. It's a pain in the neck. Did you get it figured out or not? Okay. If you go to y equals, guys, we could just put it in like it was a line, right? And then we would want to go second window and tell the table to start at 1 and count by ones. because then it would put in a 1 for us, a 2, a 3, a 4, okay? Now, when you go to the table then, the actual sequence is here, 5, 8, 11, 14, 17. Everybody getting this to work? You're just putting in a line and going to the table, okay? The thing with this is I can scroll up and find other numbers. Do these really exist in my sequence? No, my sequence starts with 1, okay? So the fact that it gives you some values that aren't really on there is the only difference here. Any questions about using either of those old school ways? Yes. Are you in sequence mode right now? That's why. And I'm going to show that right now. Okay? If you go to mode, guys, and put your calculator in sequence, so go all the way over to sequence, and then go back to y equals. You get some crazy business. Now, I will take a brief commercial break here to show you something on the newer calculator. All right, so if you have the very latest calculator, it may have some extra junk on here, but this is what we're going to go with. Now, I got to switch to the next slide here. This is what all this means. Please note this on your sheet so you know where to find this later when you can't remember how to do this, okay? N-min stands for N-min stands for your minimum term number. It defaults to 1, and we have only used 1 so far in this class, okay? There are times, you could tell it to start with any term number, but there are times, and this is literally the N number, the term, like 7th term, 8th term, 9th term, okay? There are times when you want to use 0, and we're going to do some application problems eventually, even today one, where we could use term 0. Because it's before anything even starts, okay? In an application problem, I could say there's initially 1,000 bacteria here, and they start dying off. By the end of day 1, term 1, there's already something happened. So you could put that initial amount in as term 0. All right, we'll do that in a little bit. The second part, this u sub n right here, okay, is where you plug in a formula, either recursive or explicit. Recursive is a little bit tricky, and you have to use a particular u on your screen. We talked about this, didn't we, that u sub n is really just the same as a sub n, okay? Your calculator doesn't do subscripts. So we're going to type un minus 1, and it's going to look like this. But if we use the u from the right spot on the calculator, it knows that you mean this to be a subscript. All right, last thing, this is the confusing thing. This u sub n min means u sub, whatever you put up here, 1. In other words, this says what is the beginning term that you want it to start with, the value of that term. You don't have to put anything there if it's an explicit formula, because it'll put a 1 in and generate that term. If it's a recursive, remember you have to tell it where to start. All right. I think this is confusing because I wish it said in this order. It said, first of all, what term number do you want to start with? What is the value of that term? And then what's the formula to find the rest? But that's not the order that they put it in, so I have to live with it. All right, let's try the one we were just doing real fast, the 3n plus 2. All right, leave n min 1 and type here. If you're in sequence mode, you should get an n now, literally, when you type 3 and then the x button plus 2. Everybody get an n? And now if you go to the table, it generates the sequence, but if you arrow up, it gives you errors because it only starts with term 1. So everybody's working? Anybody have a question? All right, so let's try this question number 1 right here. So we want to type this in and find the 8th term of our sequence. We could just put an n in by hand, easy peasy. But we're going to do it using the sequence mode for fun, okay? We're going to leave the first one 1. And then we're going to put the sequence in here. is it n cubed, guys? I can't read that. Okay, parentheses n to the third, arrow to the right, minus 1. Why did I need parentheses? Do I need the parentheses? Because it's all over 2, right? I can show you how to not use the parentheses. We had this discussion last period. Okay, for now, let's just look at the sequence. Okay. If you go to the table and you scroll down and you want to find term 8, it says term 8 is 255.5. That column always has a limit on the number of places it will go. So if you arrow over onto it, then at the bottom of your screen, you'll be able to tell, was it exactly 0.5? And as you can see down here, it was. So it's 255.5 for term 8, which we could have just put an 8 in, right? This is, I don't know what 8 to the third is. I go to the home screen, 8 to the third is 512, minus 1 divided by 2 would be 511, divided by 2 is this, okay? That's how I got that. All right, I did want to show you one other thing really fast. How many of you know how to do the fraction button on your calculator so that it lets you type top and bottom? Not very many of you use this, okay? Guys, alpha 1. Alpha y equals. Alpha y equals. Choice 1. Now you get 2 little boxes. And then you could type in the top box n to the third minus 1. And in the bottom box 2. And you wouldn't need extra parentheses. That's all. Does anybody use that regularly? This was very curious because Kendria has a calculator that does this, and when she typed it in, she always uses that fraction button, and when she typed it in that way, it knew to put all these answers as fractions for her. Mine won't do that, though, but it put it as fractions because she had entered it as a fraction. So, I don't know, that must be some feature of the new, hers is the one that's really new. All right, how would we get the fourth term by hand? What kind of formula is this, guys? Anybody awake out there? This is recursive. So how would you generate this sequence? The first term is 7. The second term is 2 times 7 plus 5. 19? Is that right? How'd you find the third term? Guys, you're going to have to be able to generate a sequence from a recursive formula. How do you find the third term? Take the last term, which was 19, and you put it in. 2 times 19 plus 5 is 38 and 5, 43. Is that right? The next one would be 2 times 43 plus 5. Okay. Let's try it on the calculator. How are we going to do it on the calculator? You haven't done this before, okay? Go to y equals. This time you have 2 new things, okay? You're going to leave the top one 1, but scroll down to that third one where it says u sub n min. This is where you want to put in the value of the first term. So 7. Remember how I said I don't like the order it does it? Okay? So term 1 is 7, and that's the first and third line there. Now arrow up to u sub n and put the formula in. You're going to type 2. Now you want it to say u sub n minus 1. You have to use the u that is above the 7. So it's second 7 to get that little u. Then parenthesis n minus 1, close parenthesis. And it knows when you use that little u that you're talking about a subscript when you put that in parentheses there. And then plus 5. Now if you go to your table it should have generated, if you go to term 1, 2, 3, the numbers we did, 7, 19, 43, yes? What was the fourth term then? Fourth term was 91. Okay, maybe could have found it faster by hand, I don't know. But if I ask you for the 32nd term, I don't think you want to use this formula very long. Is this arithmetic, geometric, or neither? To be arithmetic, you have to be adding a common amount. First time you added 12. Do you add 12 the second time? No. The first time you multiplied by like 19 over 7. Does it look like you multiplied by 19 over 7 to get 43? I don't think so. This is neither. This is when the calculator comes in handy, okay? Now, before I go anywhere else, yes. Okay, can you bring it here? You have something typed in wrong. Did I put the 2 in front of mine, guys? The 2U? I did, didn't I? Because I got the right sequence. Plus 5. Okay. You didn't have it on auto, so it was using old values. On the left, it should say 1, 2, 3, 4, 5 for the sequence number. Anybody else having trouble? All right. Before we go any further, I want you to do something weird. I want you to go to Zoom 0. Now, it's really hard to see on mine, but can anybody see what this is doing? Yes. Okay. There is a graph that corresponds to this. Does anybody know how it's graphing those points? Where are those ordered pairs coming from? Term 1 is 7. Term 2 is 19. Term 3 is 43. Okay, if you hit trace and arrow along, yikes. Well, that's because they're not pretty numbers. Oh, mine is in R theta. Okay, format, rectangular coordinates. Now if I go trace, is yours giving you nice numbers? Like if you go to the fourth term, it says 91, right? Okay. Any questions? All right, the next thing we want to talk about briefly is this notation. When would you use A sub 0 or U sub 0? I talked a little bit about this. If you have some initial amount and you don't want to call that term 1 or day 1 or whatever your thing is, okay? New vocabulary, converge, diverge. Says we've talked about the end behavior of graphs in the past, okay? Approaches infinity, approaches negative infinity, approaches 0. You've learned that as the domains of some graphs approach infinity, far off to the left or right of the graph, the range changes and approaches a number called the limit, okay? If a sequence has a limit, then it is said to approach a particular number and converge. Everything else is called diverge. Okay, diverge doesn't necessarily mean part of it's going up, part of it's going down, or it continues to go up or continues to go down. It's just everything that doesn't converge. Converge, a graph will converge. For example, here's a really easy one, guys. If I start at 4 and I tell you to keep multiplying by half over and over and over and over, what's going to happen? It's going to get really, really close to 0. That's a converging graph, okay? And if you graphed it, you would see that. Everything else is diverging. So if we graph and get this, converging, diverging, diverging, okay? Converging, diverging gives you a formula up here, but it's multiplying by -1/2. So it goes positive term, negative term, positive term, negative term, positive term, negative term. But are they still getting closer and closer to 0? So this is converging because it's getting smaller and smaller. This is a horrible equation I wouldn't want to have to think too hard about, but because it has a -1 to the nth power, it goes positive, negative, positive, negative. The problem is it's not really approaching any one number, right? Just jumps back and forth. This is divergent. All right. What about this one right here? If you kept adding 4, adding 4, adding 4, adding 4, that would be divergent. It would, in theory, approach infinity, but that's not convergent, okay? The end behavior would approach infinity, but that's not considered converging on infinity. It's just called divergent. All right, what would this sequence look like, guys? Generate some terms for me on 4C here. If I put in a 1, what do I get? All right, guys, I got people on their phones. I got people watching movies. I got people reading books. New vocabulary on the quiz. You want a 5. Okay, if you put a 1 in here, you'd get out -3. If you put a 2 in here, 3 times -1 squared would be... You got to put it in as an exponent, yeah. If you put a 3 here, you'd get a -1 times 3. Right? Just going to keep multiplying by -1. So convergent, divergent. Okay, what about this one? 64 is being divided by 2 and some number n. So the first term, if I put a 1 in there, what would I get? If I put a 2 in there, 64 divided by 4 would be, if I put a 3 in here, 64 divided by 6. If I put a 4 in there, 64 divided by 8. If I put a 5 in there, 64 divided by 10. Is it going to get smaller and smaller and smaller, closer to 1? It's never going to become negative, right? So this one is convergent. Can't we find what? You want me to graph that one on the calculator? If I put it in the calculator as, I don't want to put a first term in because it's an explicit formula, I would type 64 divided by the quantity 2n so that the 2 and the n are in the denominator. Okay, put in n min as 1, and u sub n min, don't put anything in, and then do a zoom 0. And it shows it right here as a bunch of little dots getting closer and closer to 0. Now you good? Okay. It's really hard to see, and I don't know how to make those dots bigger. Convergent or divergent, on the quiz, I don't actually give you a formula. So you can graph it if you can figure out a formula, but I don't actually give you a formula. What's this one doing? Can anybody tell? What is it doing? -2 -10 -12. Is it going to approach any particular number? No, it's going to keep getting smaller and smaller and smaller and more negative. Okay. What about this one? This one we could graph. Okay. Practice one more time. -1 to the power of n, all divided by quantity 2n minus 1. Zoom 0. Okay, or I could look at the table of values. It's getting smaller and smaller. It does go negative, positive, negative, positive. But are they still getting closer and closer to 0 if I scroll down here? Okay, so that one is convergent. Let me give you an example of what's on the quiz. That's not how you spell convergent. On the quiz, guys, it might say this. Convergent, divergent. Okay. It is approaching 0. That is called convergent, though. You keep getting the vocabulary backwards. All right. What about this one? It is divergent. It is going to keep adding 2, and so it will get bigger and bigger and bigger. Okay? Any kind of arithmetic sequence that graphs as a line is not going to be convergent, right? By the way, it doesn't have to approach 0, guys. If I said 2 times 1/3 to the n plus 5, this is going to approach 5 eventually, okay? Because of that plus 5. All right. A series, new vocabulary word. A series is when you have a finite sum or even an infinite, a finite series or an infinite series, and you add them up. Sequence, sorry. A series is the sum of all the terms of a sequence. I am not going to use this vocabulary very much, but it's called an nth partial sum when you want to find the sum of like the first 5 terms. They will say the 5th partial sum on the quiz. I literally wrote the sum of the first 5 terms. Okay? And that notation would be S sub 5. We're going to do sums of arithmetic sequences on Tuesday and geometric sequences on Wednesday. All right. To find a 4th partial sum of something like this, you could generate it in your calculator and then just add up the first 4 terms. All right. This slide talks about finding the sum of an infinite series. If the series is converging, you can find the sum even as it approaches infinity. Their example is if you were adding 0.1 plus 0.01 plus 0.001, it eventually would approach what number as you kept adding another, would approach this, right? Which is 1/9. We're not doing much on infinite series today, or at all. This is the last big thing you have to know, guys, is this sigma notation. This sigma notation reads, okay, the summation from n equals 1 to k of some formula. So I would probably read it like, oh, and I wanted to tell you, sometimes it'll be out in front like this, okay? This would read to me, find the sum of the first 6 terms of the sequence 3n plus 2. All right. They don't always start with n equals 1, by the way. They could do this, and that means find the sum of terms 4, 5, and 6 for this sequence. All right. You guys are super in luck, though, because you can do this on your calculator, except if I were to give you this. All right. What is this sequence doing? This is a horrible sequence. Can anybody figure it out? Wow, she's fast. Okay, we're to find the 7th partial sum. What does that mean? Anybody get that partial sum business? It just means find the sum of the first 7 terms. Okay, so we had -22, -10, -1, positive 11. Whoa, what's the next one going to be? Because I added 10, then I added 9, then I added 8, then I added 7. How did I do? 1, 2, 3, 4, 5, 6, 7. Now, if I just added all those up, the 7th partial sum is 63. Okay? Oh, thanks. Is it right now, though? The rest of the numbers are right? Okay, thank you. You were trying to add it up and weren't getting 63? Yeah. All right, my bad. All right, let's use the calculator. You ready? This one is in summation notation, and you can use the calculator. 2 places you can find it. Go to Math, and then arrow up is faster, but you can arrow down. It's choice 0, summation symbol. And as long, whoops, it's got to be in the home screen, Hofbauer. As long as you have the newer operating system, it'll just let you fill in these little buttons. So you can, little boxes, you can go n equals 1 to 5, where my formula is 4n minus 3. And it'll tell me, here they generated them all for you, but it should be 45. Yep. Okay. I just need to plug them into another calculator. Let me show you the old school way. I will fix those before the quiz. Okay, I can turn those back on. But the other way to do this, if you didn't have this, guys, you would have to go second list, over twice, and find the word sum. Then second list, sorry, second stat. Second stat to list. Over right to the one, right to the once to find sequence. Yes. Sum and then sequence. And then I would put it in 4n minus 3, variable n. I want terms 1 through 5, counting by ones, which you can leave blank. And then it would add them up and give you 45. But I'll turn it back on. I forgot that that was disabled on some of them. All right. So we could do this one. I could probably do this faster by hand. What do you think? It only wants 4 terms. Okay, if I put in a 1, I put in a 2, I put in a 3, I put in a 4. This is 4 plus 2 plus 1 plus a half is 7.5. Or 15 halves. Okay, how does he find it on the calculator, guys? Okay, I have a shortcut for you. Paying attention? It's also under alpha window. Alpha window, no, choice number 2. N, 1, 4, 2 to the n, arrow to the right, divided by 4. Okay. Find the 6th term of partial sum here. You would have to put in and find all 6 terms and add them up. You can type these on your calculator. Be very careful on your calculator. This one will generate an extra parenthesis here, and you want to put all this inside those parentheses. All right, I'm going to do this application real fast because it says you have an air mattress and you're pumping out the air.
That's negative.
Well, kind of. It's not really negative. It's removing it. If it starts out with 20 liters, find the first 3 terms representing the amount of air that remains after each stroke. So is 20 liters after the first stroke out? The first pump removing the air? No, it's before you ever start. It's term 0. There's 20 liters in there. Then you are removing, how do we remove 15%? 1 minus 0.15 or times 0.85. So if I wrote this as an explicit, I could say starting with 20, I'm going to multiply by 8.5 once, twice, 3 times. I could write it like that. Or if you wanted, did anybody already do 0.85 times 20? It actually starts with 17 as the first term. So you could say it's 17 times 0.85 to the n minus 1. If it is recursive, you would say the first term is the previous term times 0.85, where the first term or the zero term, either one, if you do 0 is 21 or the first term is 17. Would this converge or diverge? To what? Yeah, this one would approach 0 air left in there, right? Guys, the bookwork is on the back of the assignment sheet. It's all of you have a copy of the bookwork. The last 4 questions just give you a graph and say, is it convergent or divergent? Eric needs to do those so he learns the difference in the vocabulary words. Is someone else going to